Hello all, today we are solving LeetCode problem number 1536, minimum swaps to arrange a binary grid. So we are given an n cross n binary grid. In one step you can choose two adjacent rows, only two adjacent rows of a grid, and you can swap them. So this is the operation, and a grid is said to be valid if all the cells above the main diagonals are zeros. Return the minimum number of steps needed to make the grid valid, or -1 if the grid cannot be made valid. The main diagonal of a grid is the diagonal that is okay. So we all know that the main diagonal is this particular diagonal, right, which is nothing but n, which is 0 0 and 1 1 2 2. It goes on based on the value of given n. So the the cells above the main diagonal should have 0 as the value present within the grid. So that is what makes this grid stable or valid. So you have to swap the rows to make this grid valid. So that is the operation, and there is a condition to make the grid valid, and we want to solve this problem. So how do we solve this problem? So here they are given that we are having the given row as first row as 0 0 1 1 1 0 and 1 1 0 for the given 3 cross 3 grid. So to make this grid as a stable one, you are having 0 0 and 1 on top of the main diagonal grid. So you want to convert this grid into all zeros, which is nothing but it should be 0 0 0 above the main diagonal. So how do we do that? We have to follow the rules, which is nothing but the operation rules. You have to swap rows, but it should be adjacent. So what they are doing is swapping row 1 with row 2. So this row, the row 1 is being swapped with row 2. So row 1 and row 2 is swapped, and hence we are getting this particular value or particular grid. And again swap row 2 with row 3, then we are getting this row this grid updated to this particular grid. And finally swap 1 with row 2, we are getting the updated grid to be the grid which satisfies the condition, which is nothing but all the 3 zeros on top of the main diagonal element. So here it is taking us 3 steps totally, so it is due to that reason we are returning 3 as the output here. So how do we do that? First thing, we have to understand when does the grid becomes valid. So it is on top of main diagonal element, we need to have all zeros, right? So this is in case of 3 cross 3. What if in case of 4 cross 4? So you have 1 2 3 4 elements as diagonal, and then here you will have 3 elements, which is 1 2 3 and 1 2, and here it will be 1, and there you go. So this much values, this much cells, which is 1 2 3 4 5 6 cells should be 0, but here the 3 cells should be 0. So this is the first observation, and next thing you want to note is you have to track the zeros in each row. So when you consider this, you have to note the trailing zeros, so which is nothing but continuous zeros. So you have to count how many trailing zeros occurs on each row. So when you see here for 3 cross 3 grid, for the first row, first row, second row and third row, first row it is 2, second row it is 1, and third row it is 0. So which means you need to satisfy this condition to be valid. So how do we count the number of trailing zeros? We are going to use a formula here, which is nothing but n minus I minus 1. So when you consider here n is the the value, the row and column of the given grid. So and I is the index position of the row, and 1 is the uh, because since we are following the index 0 index, we are using 1 here. So now when you are having for 3 cross 3 at 0th row, it is 3 minus 0 minus 1, which is 2, and 3 minus 1, which is oops, no, this should be 1 minus 1 minus 2. Yeah, this should be 1, and 3 minus 2 minus 1, this should be 0. So this is how you find the number of trailing zeros required. So now what we have to do is we have to swap. So first step is find number of trailing zeros, and now you have to swap. So how do we swap? So we know that we can swap the adjacent uh, rows. So if you want to swap the other rows, it costs us some operations to swap, because we will be swapping by adjacent rows. So due to that, it will cost us some operations or number of the swaps. So and also, how do we know that swap is valid? So why do we swap? We swap to get the trailing zeros. So we swap to get the trailing zeros at oops, zeros at their position. So in that case, how do we do that? For example, let us go through the example 1. So we are having 0 0 1 1 1 0 1 0 0. So in this case, we know that here we do need 2, here we need 1, and here it is 0 trailing zeros to make this particular grid valid. So in this case, this is the given one. So how do we swap? We swap that these two values becomes uh, two zeros. So you can see here this particular row has two zeros. So we will swap with the between these two, and then we move up here. So what happens here is when we move this and when we swap this comes down here. So let me run step by step. So we swap 0 0 1 and 0 0 1. No, this should go up and then it should go up. So in that case, this will be 1 0 0 and 1 1 0. So this is the first step, and in the next swap this becomes 1 0 0, and this row get pushed down, which is 0 0 1 and 1 0 0. So this is the step 2. So now we are satisfied with the zeroth row. So now talking about the first row or the second row, based on zeroth index it is first row, and based on one index it is second row. So for this you need this to be the 0, because you need these three the zeros to be, sorry, these three values to be zeros. So in this case you can see you can swap this with this so that it becomes 1 0 0 and 0 0. Oops, this should be 1 0 0 and 0 0 1, and this cost us the third operation. And now you can see all the values on top of this is 0. all top of the main diagonal element is 0. And now this cost us 3 operation, and we return 3 operation because we satisfy the condition, and hence the grid, this particular grid is valid. So this is the idea which we are going to use to solve the problem. And yeah, with this observation, let us go ahead and code this up. So first thing is we have to define a function which will calculate that number of trailing zeros. So we start with n is equal to length of grid, and now define trial zeros, and we pass in the row. Now we find we have to calculate the number of trailing zeros. So we will have count is equal to 0 first initial value, and for I in range we start from reverse in -1 till -1 and decrement by 1. And then now if row of I, this is I, is not equal to 0, then we break, else we increment the count by 1 and return count. So this is about the trailing zeros function, and now we are going to build an array using this trailing zeros by counting each trailing zeros in the row. So nums is equal to, this will be a list of, we call the function trailing zeros by passing in the value, that is row, for row in grid. Yes, and we get all the values here, and now we will start calculating the operations. So we have the result which is equal to 0, and we for I in range of n, and then now we will have the target value which is nothing but n minus I minus 1. So target value which is n minus I minus 1. So you need this much amount of number of zeros, so through which you will find the rows which we need to swap. So if the nums of I is greater than or equal to target, so in that case you will continue. Okay, so else you will find the row value and you can swap. So for tracking this, we will have a variable which is found is equal to false. This is to track if we found the rows which is not this condition, so that we can swap those two rows for calculating the minimum swaps actually. So now for j in range, we start from I plus 1 till n, and if nums of this is j is greater than or equal to target, right? So in this case you will increment the array by calculating the number of operation, which is nothing but j minus I. So result will be incremented by j minus I. So this is 1, and now what you do is you again you swap. So for that we will iterate one more loop for k in range. We start from j till I, and this will be decrementing by -1. So here you will have nums of k is equal to nums of k minus 1. So you swap it, and now you will have, out of this you will, you are swapping because you have found row to swap. So because of that, you will update the found variable to true, and next thing is you break this, right, and you move to the next next iteration in this I, because you move to the next row for processing the next particular row. So here, if you did not find if the found I mean the if the found variable is still false, which means you did not find any proper rows which satisfies the condition, then in that case you return the value -1, which means you cannot perform swaps to make this arrange the binary grid. So in that case, if not found, which is if it is a false, then you return -1, and if everything goes well and this loop is done, then you return result. And yes, there you go. Let us run this code. Oh, there is some issue, and this should be I, because it is not 1, because we are swapping two rows, which is j and I, so this should be j minus I. So let us run it and submit it, and there you go. Thank you.